Alright guys, welcome back. So this would be part 2 of lesson 4.2. We're trying to understand what exactly the second derivative really telling us regarding to the first derivative and the function value. So I believe we left off where we first kind of described the two graphs, what's the same, what's different, and we were just going to use a new definitions. So notice that the first graph here, f of x itself, the derivative, the slope of tangent lines are increasing. So it is increasing. You notice how the graph has a slightly different turning point there, so it's kind of turning up like that because we have a positive tangent slope of tangent line. That means first derivative is increasing, whereas this one here, the first derivative is decreasing, so it has slightly different turning point there. So in mathematics, we captured those different type turning points for a graph. We call that the concavity of the function itself. So let's go ahead and define what that is. So definition. Okay. All right. Okay. So we define it as the following. So definition of concavity. Okay. So we say that the graph of f. So we say that the graph of f of x, or the function f of x, is considered to be concave upward. So concave upward, right? Concave upward. On a given interval, on an interval, call that interval AB. Okay, if the first derivative is increasing on that interval, and that's exactly what we have right there. All right, so we have first derivatives increasing, so the graph is kind of turning up like this, so that's concave up. Okay, all right, and then suppose what does it mean for a function to concave downward? Okay, we say that the graph of fx is concave downward, on an interval, okay, AB, if the derivative function is, instead of increasing, it's going to be decreasing on an interval AB. So let's go ahead and highlight that, the concave downward versus concave upward. So if it's concave upward, that means the first derivative is increasing. And then if it's concave downward, that means the first derivative is decreasing. And you can see that up here, right? So you see that first derivative is increasing, so the graph is concave upward. And then first derivative is decreasing, so the graph is concave downward. Okay, so now let's bring in the second derivative. What does this mean? The second derivative is saying that, all right, it's saying that, so furthermore, let's say furthermore, okay, furthermore, all right, if the second derivative, if f double prime of x is greater than 0, okay, if f double prime of x is greater than 0, then f prime of x is increasing, and therefore f is concave upward on that interval. Okay, so there it is. There's a relationship between the three functions there. You have the original function f of x, you have the first derivative function, and you have the second derivative function. So the second derivative is positive. That means the graph is concave upward. That means the first derivative is increasing. So the three functions kind of go in hand there. So the similar case of this is, what if f double prime is negative? Then the first derivative function is decreasing. All right, and then the function itself is concave downward. All right, so let's go ahead and box this here. This is the important relationship between the three functions there. So I would put this in a note card if I were you. So the next thing what we're going to try to do is capture this concept of concave upward and downward through different type of graphs, or this different type of a variety of concave upward and downward. Okay, so let's look at let's say f double prime x is greater than 0 on the function AB, excuse me, on interval AB. So this will establish concave upward type of graph. So we have these type of graph here. We have the function can concave upward like that. Concave upward, okay, on interval AB, and then you have another one where it's like this here, and then here you have concave upward. Okay, so AB, AB, AB. Okay, so what's going on here? Why do we have concave upward? So notice that the derivative of each graph is increasing. Okay, so you know this is a negative slope, and the negative slope are increasing, meaning it's going from negative to positive, whereas here it's going to decrease. Well, the slope are increasing from negative to positive. Okay, and here it's already being positive, so it's going to keep increasing. Okay, so what's happening here? We can say f prime is negative, but let's say and f prime is negative and increasing. Okay, whereas here we have f prime of x is increasing from negative, is increasing from negative to positive. All right. The last case here we have f prime of x is positive and it's increasing, so it's increasing in general there. All right. So these are three different type of graphs. We may say that the functions has a behavior concave up. All right. Let's look at another. Let's look at concave downward. Sorry. So this is where we have f double prime of x less than 0 on interval AB. So this would be concave downward. All right. So let's look at those different type of concave downward. So we have a graph like that, and then you can have a graph like this, and then like that. Let's say this is AB, AB, AB. So notice that the slope tangent lines are positive, and it's getting less steeper and steeper, so it's decreasing, whereas this one here, it goes from positive of slope tangent line to negative, so that's decreasing. And here it goes from negative slope of tangent line to even steeper negative slope of tangent line, so it's decreasing in that sense. So we say f prime is positive, but and decreasing. Whereas this one here, f prime decrease from positive to negative. Yep, decrease from positive slope to negative. Okay, and over here we have f prime of x. It's a negative already, but it's getting more negative. So f prime is negative and decreasing. Okay, so let's see what we have so far. Okay, we say that if the function has a behavior behavior to be concave upward, that can be described through the derivative of the second derivative, and if we evaluate second derivative is positive, then we say that the function is concave upward. That's also indicate that the first derivative is increasing. Okay, and if the second derivative is negative, that means the first derivative is decreasing. That means the function is concave downward. And we look at different type of concavities here. We have positive concavity, which mean concave upward, and then negative concavity mean concave downward. So that's what this video is showing here. Just kind of understand visually what does the word concavity is saying, and how do we tie that to the first and the second derivative. Concavity is just describing, how the graph is turning at certain, shape. So, this one is kind of like this here, this one kind of like that, this was kind of like up and down. So just the way the graph is turning. That's another way of looking at it. In math, we use second derivative to describe concavity changes. In the next video, I'm going to show you guys several different examples and also introduce 2 more new definitions in this lesson. So I'm going to go ahead and end this video right here.